Hi, it's Jordan again, and I'd like to talk about a different experiment, one that obviously I did not conduct myself. This topic will be talking about nuclear energy and nuclear bombs. In nuclear bombs, the energetic neutrons from the fusion explosion are so numerous, causing a quote-unquote ordinary uranium U-35 will also fission, creating a fantastic amount of energy. Thicker casings or additional stages could theoretically create massive bombs, 1,000 times the power of normal fission bombs, and low energy neutrons cause U-35 nuclei to split, and the emission of these neutrons allows the initial fission to begin and create a chain reaction. Uranium-35 and uranium-38 are two isotopes, but uranium-235 is able to cause a nuclear chain reaction since uranium-35 weighs a bit less than U-35, and also U-35 and U-38 moves at different speeds, making the chain reaction for nuclear bombs possible. And the way that it works is gas passes through a tube encased in a chamber, which allows for more of the U-235 to pass through. And to increase separation, it is sent through many more stages to enrich the U-35, and it takes about, a lot of the times, 4,000 stages to be done. And nuclear bombs, of course, are destructive weapons marked by its explosive power, and it works on the principle of nuclear fission, in which uranium-235 is used to undergo fission. When a neutron strikes the nucleus of an atom of uranium-235, it fissions or splits, and during such processes, a great deal of gamma waves and thermal energy are produced, in addition to two or more neutrons that are sent out to split the surrounding nuclei, forming what is referred to as a chain reaction. The amount of energy produced during fission is relative to the material involved. It is estimated that about 1 kg of uranium-235, when completely fissioned, releases amounts of energy that are equivalently produced by about 17,000 tons of TNT. The thermal energy released in a nuclear bomb explosion may reach temperatures of several million degrees, forming a huge fireball great enough to ignite ground fires that could destroy an entire small city. In most atoms, neutrons play a key in stabilizing role by spreading the atoms out just enough to weaken their mutual repulsion without overcoming the strong force of nuclear attraction. In stable elements like lead, everything is perfectly in balance, but in unstable elements like uranium-235, it isn't. U-235 has fewer neutrons than it ought to, leaving protons elbowing each other, kind of like schoolboys trying to get a peek at a video game that came out, or something along those lines. A boy trying to get a peek at the next new video game coming out, or something like that. Just a lot of excitement. And from time to time, this causes an atom to break apart into smaller atoms, and since this releases energy and often nuclear particles, we can call such unstable atoms radioactive. But U-235 is only mildly radioactive, and if you give exactly 2 atoms of U-235, you'd expect to wait about 7 million years for one of them to decay. But atoms are very, very small, and if you have a block of U-235 as heavy as a jug of milk, some of its atoms will be decaying every second, 24/7, which is still not enough to hurt you, just as long as you are not stupid enough to make a belt buckle out of the stuff, hypothetically. But here's where everything gets interesting. You can induce nuclear decay fission by whacking away at atoms with a supply of neutrons, and the nuclear decay is the source of such neutrons. So where is this going, you might ask? If you put enough U-235 together in the same place, a natural neutron radiation starts to stimulate more than a natural background level of fission decay, which releases more neutrons, which causes more fission, and so on, which is a chain reaction. Also, you should know that nuclear bombs are not made out of pure uranium-235 because it would be much too expensive, but rather made out of enriched uranium, which has a fewer percent of U-235 by comparison, and is far more than in nature sufficient enough to start a chain reaction. Thank you for listening to my video.